Okay, now I shall discuss on these performance parameters. Okay, so the actual details of this I/O operation, okay, depends on the computer system, operating system, and nature of the I/O channel and disk controller hardware. Okay, from figure here, this figure shows the timing of a disk I/O transfer. Okay, it has time for waiting for device and then wait for channel. Okay, it has seek. Okay, seek times, seek for the right track. Okay, rotational delay and data transfer. So this is where the device is busy. Busy searching for data. Right? Okay. Data and also transfer line. Transfer. Okay, so first to understand how this perform, you have to know the anatomy of hard disk drive. Okay, so this is basically the anatomy of hard disk drive. You can see here. Okay, there are many platters. Okay, you can see the flat surface here. Okay, there are many platters, or known as discs. Okay, many discs. Example here we have 4 discs. Right, 4 discs, and here is the actuator. Okay, where it held the arms. Okay, the read and write arms. This is what we call as the read and write arm, and this is the head. Okay, the read and write heads. Okay, read and write heads. So basically, read and write heads will move. Okay, will move to find the tracks. Okay, to find the tracks. Okay, to search for data, any data requests. So this arm will move, and this platter is rotating. It's a rotating platter, rotating this. So it will rotate. Okay. So hard disk drive use spinning disk to magnetically store information and also to retrieve, to read and write. So we shall see the anatomy. Again, this is the head. Okay, you assume that this is a movable, arm. Okay, read and write arm, and also so meaning that it can move across the tracks. Okay, so these are the tracks. Okay, these are the tracks. You can see actually there are many tracks on a platter. Okay, on a disc there are many tracks. So this is an example of a track. Okay, one track can consist many sectors. Okay, one track can consist many sectors on a platter. So basically, the function of a head is to find which sector of a track. Okay, meaning that to find the right track is the function of the head. Okay, the head will find the right track. Okay, and the rotating disc. Okay, it will keep on rotating here to find which sector, which like the beginning of sector, okay, to be read. Okay. So I hope you will understand the anatomy. The head of read and write head, the sector, tracks, and the platter. Okay, next, positioning the read-write heads. Okay, when the disk drive is operating, the disk is rotating at constant speed. Okay, this is the disk or the platter is rotating at constant speed. To read or write the head must be positioned at the desired track and at the beginning of the desired sector on that track. Okay, to get the beginning desired sector is with the help of the rotating disk. Okay, if the disk does not rotate, you cannot find the desired sector. Right? Track selection involves moving the head in a movable head system or electronically selecting one head on a fixed head system. Right. On a movable head system, the time it takes to position the head at the track is known as seek time. Okay? Seek time is the seeking track. Okay, seeking track time. The time to seek the right track. Okay, we call it as seek time. So the time it takes for the beginning of the sector to reach the head is known as rotational delay. Okay, because like I mentioned, okay, to get the right sector, okay, it will with the help of the rotational days. Okay, so the time to take from the beginning for the beginning of sector to reach the head is called as rotational delay. And the sum of the seek time and the rotational delay equals to the access time. Okay, this is the access time. The time to access the data. Okay, it's time to access the data, whether it's to read or to write. So now we know about how this work. Okay, how a hard disk drives work. So basically there are many disk scheduling algorithms. Okay, disk scheduling algorithms. So you can see here, these are the names of the scheduling algorithm, the descriptions and the remarks. Okay, I will point a few here where we will discuss in this lecture. Okay, there are many, but I will not cover all of it. Okay, we can see here RSS, this is for random scaling, for analysis, random scheduling for analysis and simulation. Okay, the one that we will discuss, okay, in this lecture is using 5.4. Okay, we just look brief on the PRI, the priority, SSTF and SSTF, scan and CScan. Okay, so 5.4 falls under selection according to requester. So this scheduling algorithm is a first in, first out. Okay, based on the first in, first out, whichever request comes first, it will be treated first. Okay, so this is the fairest of them all, the fairest among all these schedulings. So priority is using priority by process, okay, control outside of this queue management. And we also have last in, first out, maximize locality and resource utilization. Okay, for algorithms to select according to requested item. Okay, here we can see there are 5 algorithms. We will cover the first 3. Okay, SSTF is also known as shortest service time first. Okay, SSTF, shortest service time first. So we will find for shortest service time. Right? This is we will use high utilization and also small queues. Okay, small queues. Okay, next using scan. Okay, scan. It will access back and forth over disk. Okay, it has better service distribution. For CScan, C stands for secular. Okay, secular scan. Okay, this is just like scan, but it is one way. Okay, with fast return. Okay, one way. This is 2 ways. Okay, it has lower service variability. Okay. And then we have n-step scan also FS scan. Okay, like I mentioned, in this lecture we will cover on 5.4, on 5.4 SSTF scan and also CScan. Okay, just a brief some briefing on priority scheduling. So control of the scheduling is outside the control of this management software, where goal is not to optimize this utilization, but to meet other objectives. Okay, to meet which one has more priority. Okay, short batch job and interactive jobs are given higher priority. So these are among the higher priority. Okay, short batch jobs and interactive jobs. Okay, it provides good interactive response times. However, okay, longer jobs may have to wait an excessively long time. Okay, meaning that longer jobs will starve, okay, have starvation. And it's a poor policy for database systems. Database systems should not use priority-based scheduling. Okay, so before I explain the these scheduling algorithms, we first must know the scheduling criteria. What are the things that we look into this scheduling algorithm? Okay, these scheduling strategies are generally designed to treat all requests as if they have equal priority. So the objective of the strategy is to optimize one or more of the following quantities. Okay, we look into the throughput. Okay, the throughput means that number of requests processed per unit of time. Okay, meaning that if there are many throughputs, it will be better. Okay, many meaning that the number of requests processed per unit of time is better if there are many. Okay. Next, average response time. Okay, meaning is the waiting for a request to be processed. Okay, the variance of response times. Okay, whether there is no starvation or indefinite postponement. Okay, each request should be processed within a reasonable time period. Okay, the target is there should be no starvation. So the objective, okay, we want to see in terms of the throughput, okay, in terms of the average response time. Okay, for response time, you have to make sure, okay, it should be no starvation, right? Okay, this is where fairness and predictability is measured. Okay, these are the criteria that will be looked into when using any day scheduling algorithm.